Hi and a very good day. So in this video session I will discuss the basic model of Box-Jenkins method. Okay, so there are actually three basic models. Okay, after this I hope that when you read particular time series literature, when you read about autoregressive model, moving average model, okay, or autoregressive and moving average model, I hope that you understand it is actually based on Box-Jenkins method, where we perform the model towards a stationary series. Okay, so let's take a look at the first model. Okay, the autoregressive model. Okay, here to define the autoregressive model, it is actually the current value is equals to the function of its previous value, okay, plus an error term. So here when you see that, here again we have this particular coefficient for our past observation, as it will become the weight, okay, the weight of the effect on the previous value towards our current value. Okay, so here we say that the phi coefficient here we will estimate. Okay, we will estimate the value, right? So mathematically, okay, we can write ARP. Okay, P here is until what observation, what past observation that we will added in the model to represent the current value. Okay, that's why, because of this particular specification, that's why we need to determine what are the most simplest, the most simplest model to represent as AR model, because we can add as many leg as possible. Okay, so here is the autoregressive model. Okay, we use the phi symbols here to represent the coefficient for our yt minus 1, and it represents the weightage, what are the impact of our previous value towards our current value. And our error term here is assumed to be ID with mean zero and variance, okay, sigma square of epsilon. Okay, so our current value will become the dependent value. Okay, so again, when we use the backward shift operator to represent the AR model, okay, this is how we write the model. Okay, so suppose that we rearrange our okay we rearrange our AR model here, okay, from right side to the left side, and then for yt minus 1 is actually b, for yt minus 2 is actually b square yt minus 1 b yt, this is bp yt, okay, and so on. So when we rearrange, okay, we can write the backsheet operator as this form. Okay, right. It is actually when we perform AR model, okay, your textbook mentioned that, okay, we actually need beyond order 2. Okay, that's why for this example, okay, for AR1, this is the equation that represent AR1. Okay, the phi1 yt minus 1 plus, okay, epsilon t. So when we write the using backsheet operator, this is the form. Okay, and for AR2, okay, this is the form for AR2, and for by using backsheet operator, this is the form. It is actually easier for us to see whether to know the model of our autoregressive by writing it in terms of backshift operator. Okay, right. Next, moving average model. Okay, like the name itself, I hope that you can differentiate between the moving average that we learned in the first chapter. It is actually different. Okay, when we talking about moving average in Box-Jenkins model, okay, this particular moving average is actually the function of error terms. Okay, again here I will use the theta to represent the coefficient of uh, our error term. Different What are the difference between AR and MA model? Instead of the function is the function for the previous YT for AR, this is the function of previous random errors. Okay, and as we can see here, even the notation of this particular error is different. Okay, so for AR we use plus notation, plus symbol. Okay, and for MA we use minus notation. So this is the thing that you need to understand, right? Okay, and again this theta here will be the parameter, or the weightage of this random error will affect the current value. It is the coefficient will be, the parameter will be estimated. Okay, right. So again we can write using backshift operator. Okay, okay uh, okay so epsilon t minus 1 here is actually b epsilon t. Epsilon t minus 2 is actually b square epsilon t. So we can write by using backshift operator. Okay, and for MA1, okay, by using backshift operator, this is the way on how we write MA1. Alright, okay, that's moving average, and sometimes, okay, we need both AR and MA to represent our current value. Okay, by combining these two uh, by combining these two model AR and MA, we know it as ARMA model. Okay, under ARMA models, okay, the series is still stationary. Okay, we no need to perform any differencing operation to make sure that our series is stationary. And also for AR and MA model, okay, our original series is stationary. When it's stationary, based on the pattern of ACF and PACF, I will explain it later in the application part. Okay, we can determine the order of the P and Q. Okay, again, before I forgot, okay, for AR we represent is as P. Okay, how much the past observation that we'll add in our model, and for MA we will use Q. Okay, so here to represent the ARMA models, okay, so we can you rearrange the terms. Okay, how many AR, how many MA. Okay, so this is the way we can write. Okay, for example here we use 2 1 to write the ARMA model. So this is the way we write, and by using the backshift operator, okay, the 2 here is P. P equals to 2, Q equals to 1. So that's why, okay, as we can see here, your P is, okay, you will have B square, because P is equals to 2. So for here, the backshift operator is up until B only. So Q equals to 1. So That's why it is easy for us to write it in terms of backshift operator. Okay, so for the past model, okay, we assume that our original series is already stationary. Okay, what if our series is not stationary? So when our series is not stationary, we need to perform uh, the differencing in order to make sure that our series is stationary. Alright, so that's why this is the model that we need where we call it as autoregressive integrated moving average. Okay, the integrated here means that we will perform the differencing first uh, to transform our data series from non-stationary to stationary. And here we will use D to denote the number of time variable yt needs to be different. Okay, I already discussed about the first order differencing, the second order differencing to change from non-stationary to stationary. Okay, so here we will use a new symbol WT, where this WT is actually the series to represent the first difference. Okay, here example ARIMA 111 is written as this. Okay, instead of YT we use WT because this WT is uh, represent the first difference. Okay, YT minus 1. Alright, but of course we can replace the YT with the WT with YT. Okay, so here is the example on how based on this ARIMA 111 we can at the end of it we return it as YT. Okay, so you can read this this particular this step on how we write this YT. Okay, YT and WT. Okay, remember okay, in ARIMA models, okay, this is actually the most popular Box-Jenkins method because like I mentioned before this, most of the econometric series it is not stationary, so we need to perform the stationary we need to transform the non-stationary to stationary first before we apply this Box-Jenkins method. That's why ARIMA is the most common model that used by past literature. Okay, right. uh, when we perform D equal to 1 means that we perform the first order differencing, and sometimes there are cases where the first difference is not enough. That's why okay, we need the second differencing, the second order differencing, and D is equals to 2. Okay, an example ARIMA 1 to 1, and the textbook discuss it is actually rarely exceed 2 for ARIMA model. Okay, so for ARIMA model it is actually for if there is no seasonal component in our series, so we can use ARIMA. And later on I will explain what are the model if there exists seasonal in our series. Okay,